Well, basic AI prompting is just not enough anymore. Beat. Everyone knows how to use a chat box. The job competition gets stronger every single day. But here is a really good news. You don't need a 4-year degree to catch up.
You really don't. I mean, the landscape is moving incredibly fast, but the path forward is actually very structured. You just have to know where to look.
Welcome to the deep dive. Today we are exploring a highly practical framework. It is called the 5-phase AI Engineer Roadmap. There is this massive gap right now, a gap between people who just talk to AI and people who build autonomous systems. We are going to map out how to cross that gap.
The timeline for this is fascinating, honestly. If you are starting entirely from zero, it takes roughly 8 to 12 months. But if you already know how to code, it is much faster. You're looking at just 3 to 6 months.
Right, so we are going to walk through all 5 phases today. We start by pouring a foundation with Python. Then we decode how AI models actually think. After that, we wire them into real applications. Then we give them private memories with RA systems. And finally, we set them loose as autonomous agents.
It is a really beautiful progression. Every single phase builds directly on the logic of the previous one.
Let's get right into the foundation. You cannot build an AI house without pouring a solid concrete slab first. For this roadmap, Python is that foundation.
Absolutely. Python is essentially the lingua franca of artificial intelligence. But there's a huge trap here for beginners.
Trying to learn the entire computer science curriculum.
Yeah, getting completely bogged down. You do not need to learn all of computer science. You only need to focus on moving data around.
Looking at the sources, that list is surprisingly short. We are talking about basic syntax, we are talking about loops, calling APIs, handling JSON data, and doing basic data manipulation with pandas and NumPy.
That is really it. To build AI tools, you basically receive an input, you call an API to process it, and then you save the useful data.
Let's ground that jargon really quickly. An API is a bridge letting two software programs talk, and JSON is a simple text format for storing data.
Beat it.
What I find fascinating is the learning method here. You don't buy a textbook.
Textbooks are way too slow for this. The breakthrough is using Fable 5, or ChatGPT.
To address your current coding level first. Then you instruct it to teach one topic at a time.
The constraints in the prompt are the secret sauce. You literally command the AI to wait for your answer. It cannot show a complete solution right away.
You force it to act like a strict professor. It reviews your broken code. It points out the exact line that needs work. It gives you a subtle hint before correcting the script.
Exactly. Because writing code means breaking code.
You know, I still wrestle with API error handling myself. It can be incredibly frustrating when a script just hangs.
Oh, it happens to every single developer. Network requests fail constantly. The data comes back malformed. Learning how to handle those errors gracefully is half the job.
The final goal of this first phase is simple. You build a tangible automation project. You pull data from an open media API, or maybe GitHub. Then you clean it up and save it locally.
Right. It proves you can actually control the flow of information. You're handling missing inputs. You are managing failed network requests. You are keeping your API keys secure.
Let me push back on this specific learning method, though. Why not just watch YouTube tutorials to learn this? It seems a lot less frustrating than fighting with a chatbot.
Well, watching tutorials creates a dangerous false sense of security. You watch someone else type perfectly formatted code. Your brain thinks it understands. But you have to physically write, break, and fix the code yourself. That builds the neural pathways in your own head.
So stop watching videos and start breaking real code.
That is the only way the concepts actually stick.
Okay, so we have our foundation. We speak the language of Python. But a language is useless if you don't understand the brain. That brings us to phase 2, understanding how AI models actually work.
This is where we demystify the magic. And again, no deep math or long proofs are required here. We are focusing on practical intuition.
The roadmap highlights a few core concepts: supervised versus unsupervised learning, classification versus regression.
Right. Think of supervised learning as training a model with an answer key. You show it 1,000 labeled pictures of cats. Unsupervised learning is just giving the model raw data. You ask it to find hidden patterns on its own.
The underlying mechanics really dictate how we build. We are talking about neural networks, transformers, tokens, embeddings, and context windows.
These terms sound intimidating, but they are very mechanical. Tokens, for example, they aren't exactly full words.
They are just pieces of words the AI uses, like syllables it digests, and a context window is the AI's short-term memory limit.
Yeah, is how much text it can hold at one time. If you overload that window, the model starts hallucinating. or it loses the plot entirely.
2-sec silence.
Mm.
I want to pause on embeddings. I hear this term constantly in these deep dives. Could you give an analogy to understand embeddings?
Think of embeddings as turning text into coordinates on a map. They turn text into numbers so the model can measure relationships. It is like plotting a dog and a wolf very close together, but placing a car miles away.
They group ideas by meaning, not just by exact word matches.
Precisely. It is how the model mathematically understands semantic relationships. If you search for feline, the model knows it is close to cat. Their coordinate numbers are incredibly close.
So the goal of this second phase is applied knowledge. You take those mechanics and write a formal model decision brief.
You have to prove you can choose the right model. You evaluate them based on quality, speed, cost, and context size.
Because you cannot just use the biggest model for everything. A fast, cheap model might be absolutely perfect for routing support tickets.
But a slow, highly capable model is different. You need that massive context window for drafting a complex marketing campaign. You have to write down your reasoning and trade-offs.
So we have this brain now. We understand how it thinks, how it stores concepts, and what it costs. But a brain in a jar isn't doing any actual work. We have to wire it up to the real world. Phase 3 is building our first LLM application.
This is the MVP stage. Minimum viable product. But there is a very strict rule for this phase. You must build a focused tool, not a general chatbot.
Why avoid general chatbots? Isn't that what everyone wants to build?
A focused app has a clear success metric. A general chatbot can answer literally anything. That makes it nearly impossible to test if it's actually working reliably under the hood.
Focused tools give measurable results. Chatbots are just chaotic black boxes.
Exactly. You want predictable, structured outputs. Outputs that another piece of software can actually read. You will likely use the OpenAI, Anthropic, or Gemini APIs for this.
The key to getting that predictability is system instructions. You use highly structured prompts. You explicitly demand valid JSON output from the model.
You are essentially building a rigid fence around the AI. You also have to manage the engineering side. You handle API rate limits. You track your token costs so you don't go broke.
And you validate the user's input before sending it. The example project for this phase is incredibly practical. It is a meeting transcript analyzer.
It solves a real problem. You take a massive, messy transcript from a 1-hour meeting. You paste it in. The application processes it and extracts the tasks, owners, and deadlines.
And it returns them in a strict JSON format. But what's brilliant is how it handles ambiguity. If a deadline is missing, the app doesn't just hallucinate a date.
Right. It returns a clear missing value. That is what separates a prompt engineer from an AI engineer. You control the behavior programmatically. You don't just chat with it.
We will take a quick break. Sponsor. Welcome back to the deep dive. We are exploring the AI engineer roadmap. So far, we built a foundation in Python, decoded AI models, and wired up an application.
But there is a massive limitation we haven't addressed yet. The knowledge cutoff.
Exactly. Our transcript analyzer works beautifully, but the underlying model only knows its public training data. What if we want it to read our own private files?
That is the problem Phase 4 solves. We build a RAG system.
RAG, Retrieval Augmented Generation. Let's define RAG simply, giving the AI a private library to search before it answers.
That's the perfect way to look at it. Instead of relying on pre-trained memory, you force the AI to read your specific documents first.
The pipeline for building this is fascinating. First, you load your private documents. You clean up the formatting. And then you chunk the text into much smaller pieces.
You convert those chunks into embeddings, those spatial coordinates we talked about earlier. And you store all those numbers in a vector database, like Pinecone.
Just to clarify, a vector database stores information as searchable numbers. Beat. Whoa. Imagine scaling to 1 billion queries across a company's entire history in milliseconds, finding the exact sentence from a 3-year-old memo.
It is incredibly powerful. When a user asks a question, the system converts it into coordinates. It finds the closest matching text chunks and pulls them out.
But I have a question about the process itself. Why do we have to chunk the text? Why not just give the model the whole document?
Well, models have strict context limits. They get deeply confused by too much text. Smaller chunks keep the retrieval highly relevant to the specific question.
Smaller chunks mean the AI finds the exact needle, not the whole haystack.
Right? And it saves you a massive amount of money on token costs. You're only sending a few relevant paragraphs to the AI instead of a huge manual.
There is a crucial safeguard built into this phase. The roadmap calls it the refusal rule.
This is entirely non-negotiable for production systems. The system must explicitly refuse to answer if the documents do not contain the evidence.
It prevents hallucinations. It builds actual trust with the user. The example project here is an AI fire article document assistant.
It is an app that answers questions about a curated set of articles. But the magic is the citations. It must link back to the exact original text it used.
This changes how you evaluate the system. You measure retrieval quality and answer quality separately.
You ask, did the database actually find the right document? That is retrieval. Then you ask, did the LLM accurately summarize it without making things up? That is generation.
So you start tweaking it. You change one variable at a time. Maybe you adjust the chunk size or the embedding model. And you watch to see if the final answers improve.
It is a highly empirical process. You are basically running science experiments on your own data pipeline.
Which brings us to the final frontier. Phase 5. Building an agentic AI system.
The autonomous worker.
Okay.
Up until now, we taught the system to read and answer. Now we are teaching it to plan, act, and verify its own work.
We are stepping away from direct prompts. We build an AI fire research brief agent, and it uses the React pattern alongside a framework called LangGraph.
The React pattern is essentially giving the AI an inner monologue. It teaches the AI to plan, act, and observe results before it speaks. LangGraph manages the steps in the memory of that entire process.
The concept of state is so central here. The agent maintains a state to keep track of its own progress.
It has to remember what it's doing. It remembers the original topic. It remembers the exact search queries it already tried. It remembers the rough drafts it wrote 5 minutes ago.
The workflow here is actually kind of beautiful. Once you hand it a topic, it doesn't just guess. It creates a formal research plan.
Then it takes that plan and searches the RG system we built in Phase 4. It actively pulls evidence.
If the evidence is weak, it doesn't just give up. It creates a new, refined query. It searches the database again.
Then it drafts a brief, and finally it turns around and verifies its own claims against the original sources.
But we have to impose strict limits on this autonomy. You cannot let it run forever. The roadmap specifies no infinite loops, a maximum of 3 search rounds.
Yeah, compute is expensive. If a claim lacks solid evidence after 3 rounds, the agent must physically remove it. It cannot just invent a plausible fact to fill the space.
There is one final, incredibly crucial safeguard here: human approval.
The system must pause its execution. It displays the final draft to the user. It physically waits for human input before saving anything to a file.
Why do we need to force a human approval step? Shouldn't a true agent be fully autonomous?
Because AI can still hallucinate or permanently overwrite critical data. You want a human checkpoint before any permanent action takes place.
Always keep a human hand on the steering wheel before saving files.
It is the only safe way to deploy agentic workflows right now. The human can approve the draft, reject it, or type in feedback. The agent takes that feedback and revises the draft again.
Let's zoom out for a second and look at the big idea here. This entire 6 to 12-month journey,
It really is an elegant progression of engineering skills.
we started by automating very simple scripts with Python, learning how data flows.
Then we learned how to choose the right brains by understanding AI models.
We wired those brains into a highly focused tool, the LLM app.
We gave that tool a private, searchable memory using a RE system.
And finally, we let it act autonomously as an agent. It's exactly like stacking Lego blocks of data. You can't build the castle until you know how the first 2 bricks click together.
Every single phase is a required brick. You cannot skip straight to building autonomous agents without understanding Python and structured prompting.
This deep dive shows that AI engineering is actually accessible. It does not require a doctorate. It just requires extreme discipline and following the right sequence.
You build real projects at every step. You document your failures. That creates a portfolio that actually stands out in this market.
Here is a call to action for you. Think about your workflow. Pick just one daily task you absolutely hate doing, a tedious data entry job. Open Fable 5 or ChatGPT and start learning Python Phase 1 today. Build a script to automate it.
Just 15 minutes a day will get you started down this roadmap.
Thank you for joining this deep dive today. I want to leave you with one final thought to mull over.
Yeah.
We just explored how one single agent can autonomously research, draft, verify, and revise a complex brief. 2-sec silence. What happens when you start networking dozens of these specialized agents together to run entire company workflows? Out to your own music.